All right, in this video, let's look at the yellow section. So number 1 here, 1 through 3, we're just evaluating these expressions. And so for the first one, remember, we're trying to figure out what exponent we'd apply to 9 to get 9 to the 5th power. Well, it would just simply be 5. Okay, anytime the base and this base, the base of our logarithm and the base if we have if our value has an exponent, anytime those two bases are the same, your answer is always going to be that exponent. But otherwise, you could look at it as, again, what exponent would apply to 9 to get 9 to the 5th. For the next one, we can't do that because the 2 and the 64 are different values there. So we're trying to figure out what exponent you'd apply to 2 to get 64. And so if you're wondering, like, how would I do this on my own? Well, you just guess and check. You could just try different exponents for 2 until you got an exponent for 2 that would give you 64. And if you did that long enough, you'd end up finding that 2 to the 6th power is 64. And so your answer there would be 6. For the last one, trying to figure out what exponent you'd apply to 1/2. Now if you notice, we're going from it being a fraction to it not being a fraction. And the only thing that will do that is if our exponent is negative. So we know that much at least. We know it's got to be a negative number. And now I got to figure out what exponent would I apply to 2 to get 32. Well, 2 to the 5th power would be 32, so 2 to the 1/2 to the negative 5th power would make that to be 32. So your answer would be -5. So anytime we go from a fraction to not being a fraction, or if this had been just 2 and our answer on the right would have been 1 over 32, so anytime it changes either back and forth between a fraction and not a fraction, we know that our exponent's got to be negative. And then you just look at the 2 in this situation and figure out what exponent you'd apply to 2 to get 32. All right, so for 4 through 7, we're solving equations. Now, some of these are exponential equations, some of them are logarithm equations. So if it's an exponential equation, we're going to have to change it to logarithm form. So right now, for this one, I notice that my base is e. So when I change this to logarithm form, we would have log base e. But that's not proper. Remember, log base e is the same as the natural log. So the natural log of our value, which would be 12, would equal the exponent, which is 2x minus 5. Now, if you wanted to take the natural log of 12 now, you could, but then you're going to be dealing with the decimal. So personally, I'm just going to wait. I'm going to solve for x, though. I'm going to add 5 to both sides. And then to solve for x, I would divide by 2. So then this is what I would type in my calculator. Now, personally, what I'm going to do on my calculator is I'm going to type this in first. I'm going to take the natural log of 12 and then add 5. Make sure that after typing in, by the way, the natural log of 12, that you close it off with parentheses in your calculator. And then I'm going to add 5. I'm going to hit enter, so I make sure I get the numerator all correct. And then I'm just going to hit the divide by 2 button to make sure then I get the denominator there. And when you do that, you get, it says round to the 3 decimal places, so we'd say 3.742 be your answer. All right, let's look at the next one. The next one, another exponential equation. Our base for this one is 10. So remember, if we have log base 10, that's the same as, that's a common log. So we can just write it as the logarithm of our value, which is 15, equals our exponent, which is 8x plus 7. So just like before, I'm going to solve this. If you wanted to, you could take log of 15 and work with the decimal, but I'm going to wait with that. So I'm going to subtract 7 from both sides. We'd have log of 15, and then we would subtract 7 equals 8x. And then to solve for x, I would divide both sides by 8. So again, when I go to type this in on my calculator, I'm going to do this in 2 steps. I'm going to type the log of 15. Make sure that after you type in the log of 15 that you close it off with parentheses. So we'd have log of 15 minus 7. And I would hit enter, and then after doing that, I would divide by 8. And when you do that, you get an answer of negative 0.728 when you round it 3 numbers past the decimal. All right, let's look at number 6. For number 6, this is already in logarithm form. So if it's in logarithm form, we're going to have to change it to exponential form. So remember, if we have a base here of 10, let me use a different color. When we have a base here of 10, that's what a common log is. When we write this in exponential form, our base for our exponent would be 10. Remember, logarithms are equal to exponents, so this would be, our exponent would be 10 cubed. And then we would have that equaling our value, which is 7x minus 4. All right, so now there's a couple ways you could do this. Now we're not going to have, when we take 10 cubed, we're not going to have a decimal. So personally, I'm just going to do that. I'm going to change 10 cubed to 1,000 equals 7x minus 4. Now we just add 4 and divide by 7. So when we add 4 to both sides, we get 1,004 equals 7x. And then with the last step again, like we would divide by 7. We're going to do that. We're going to get a decimal of 143. Point, again, we're rounding to 3 numbers past the decimal, so we 0.429. It's going to be your value for x. All right, lastly, so again, we have another problem here. This is a common logarithm again, so our base would be 10. Our exponent would be 2 equals our value, which is 2x plus 6. Well, 10 squared is 100. And then this time, to solve for x, I would subtract 6, where I would get 94 equals 2x. And when I take 94, when I do my last step here, I would divide by 2. When I take 94 divided by 2, I get 47. So x would equal 47. All right, so that's the end of the yellow section. So hopefully that answers the questions that you had for those problems.